Hey, what's going on, guys? My name is Ivan Yosuf, and in this tutorial I'll be showing you how to create a simple game using Python and Pygame. Pygame is a module designed to create mostly 2D games using Python. So let me actually show you what we'll be doing. So this is the game window, and we'll be controlling this rabbit using the arrow keys around the screen, and there'll be different sort of pickups. For example, a mushroom, and when the bunny moves over the mushroom, it eats it. So then I have this sort of plant sticking out of the ground, and when I get to it, I cannot take it. I need to dig it out first. So when I move the mouse cursor over this image, it turns into a shovel that points to the right. That means I need to press the right mouse button to dig it out. And when I do that, I get carrots. Now they are pickable, so I can eat them using the rabbit. And then I have this plant again. Again I press the right mouse button. And then I have this grass. And the grass again is not pickable. I cannot move over it. So when I hover the mouse cursor over it, I get a shovel that's pointing to the left. So I'll press the left mouse button and I get a tulip. And again, tulip, carrots, grass, mushroom, and the score increases accordingly. Each mushroom gives me 1 point, tulips give me 2 points, carrots give me 3 points. And that's pretty much the game. Before we get started, I just wanted to tell you that this is not a beginner's course, so I will not be teaching you what are variables, how to create functions, or how to use conditionals or loops. I expect that you already know the basics of Python. But if you don't know anything about Pygame, don't worry. I'll try to explain as best I could how to use that module to create some basic interactions. Again, like I said, we'll be doing like really basic stuff, like listening for keyboard events, mouse events, and controlling game assets like images. So we'll actually start by creating, and also I'll be using the Mu editor. There are different editors for Python, but I'll be using the Mu editor because it's really beginner friendly. It has very little options, and I really like it for using small projects using Python. Also in Mu, like here in the bottom right corner, there is this cogwheel, and when you click it, you get this window, and here for third-party packages you can import the packages that you need. For example, I wrote Pygame, so if you need to import Pygame, you do that, you click OK, and it will automatically download the Pygame module for you. So if you're using Mu, you need to use the third-party packages tab to import Pygame, and here you can see it. Here's the Pygame module. That means I have access to the module and to its functions. Okay, so I'm gonna create on my desktop, I'll create a new folder called game, and inside of the game folder I'll create actually a new folder called data, and also I'll create a new document called game.py. So here this will be the main game file, and all the resources will be loaded from the data folder. So inside of the data folder, I'll create a couple of folders. I'll create fonts, and we'll be using only one font, but I'll be using the plural because I like it better. Then I'll create another one called images. I'll create another one called sounds, and the last one called cursors. And again, we'll be using only one cursor, but I like to make them all plural. So first I will go to this link, and all the links to the resources will be linked under the description of the video, and also the whole project will be put on GitHub, so you'll have direct access to it. So if you don't want to load the resources one by one, you can just, get it from GitHub, and there'll be a description under the video. So the first one will be the Bunny Funny font, and you can download it. So I'll go to fonts and I'll extract it here, and here is the bunny font. Then I will go to this animal pack, this link, and I will download the rabbit. Oh, here it is. Now I will download the 64 version of the rabbit, and I'll put it in the images folder. Then I'll go to this will be the background image, and I'll download from Unsplash. I'll download the big version, and then I'll scale it. Download. Yeah, I'll call it grass, but because it's too big, I want my game to be 900, and I want the whole image to appear, so I will scale it. So 900 by 600. And here it is. Sorry. How do I refresh? Okay. So as you see, it's now 900 by 600. Okay, and from the spring icons, I'll need the plant, and for these resources, I'll take the 32-bit versions. So this is the plant, this is the carrot, the grass, the mushroom, and I believe the tulip is the last one. Okay, I'll copy all these inside of my images folder. Oh, I forgot the cursor. So for the cursor, I'll use this spade image, and it's from the same site. and I'll download the 16 pixel version. Okay, and last one, I need to download my sound files. So the first one will be this one. Now this is a hit sound, but I'll use it as a digging sound. So now actually I need to log in. And download this one. I'll save it and I'll call it dig. I'll also need a crunch sound, and I'll save it, and here's a preview. That's when we eat a pickup. Eat sound. And also I'll have a background music. I'll call it from bandsound.com. It's free to use, and we'll add it at the end. This will be the background music that will be playing as long as we are playing the game. So this is a preview of the game, of the music, and I will free license with attribution. I'll download it, and I'll call it BG music for background music. And these are actually all the assets we'll be using inside of our game. So with that, we can go ahead and get started. Now I will open Mu, and I will open the game file. So I'll go to the desktop, game, and I'll pick up the game file. As you see, it's empty. Now, before we start, again I want to tell you, you need to download the Pygame module, and if you're using Mu editor, you can just write Pygame inside of the window and press OK. If you're not using Mu editor, you need to use it pip install. So open the command prompt and pip install Pygame, and that will install it globally. And I already have the Pygame installed globally, so it's not downloading anything. But if you're using a different editor, you need to install it globally in order to use it. And once this is done, and I'm not exactly sure if pick it up. Once this is done, we can import Pygame, and then we need to initialize Pygame, and at the end we need to quit. So between these two lines we'll be writing our program, and if right now I run this one, you will see in the console I have this hello from Pygame community, which means that the Pygame module is present and it's successfully imported. So first I need to create a screen. So the dimensions of the screen will be 900 by 600. And then we need to instruct Pygame to create a screen with these dimensions, and this is the command pygame display.setMode. And inside of setMode we give the tuple that contains the dimensions of the screen. And before we can run this program, I believe we cannot run it right now, it just pops up and disappears. You see this? And the reason why this is happening is because there is not a game loop. Whenever we're creating a game using Pygame, we need to create a game loop that will be running endlessly, so all the time. So in order to create that game loop, we need to use a while loop. So we'll set a variable called running. It will be equal to true, and while running, so this is an endless loop. This will run all the time. Unfortunately, if I run it right now, okay, I need to put pass here. So I cannot close it. So the game kinda hangs. So I need to stop it forcibly from here. So in order to close the game from the X, I need to catch that event. So I need to make a loop that will run through all the events from Pygame. So this command will get all events, and then I need to listen for a specific event. So if the event type is quit, this is the X, I need to set running equals to false. Now this is the game loop, and when I run it, I have the window, and now the X is working. This X corresponds to this command, pygame quit. So when I click this X, it means I'm quitting the endless loop. And here, everything is working now properly. Now, one other thing I want to do is I want to set like a caption, like a title, sort of. So I need to write Pygame display set caption, and our program will be called Bunny Picnic. And now when I run the program, you see the caption of the game window is Bunny Picnic. We change it. We can also change the icon, but I'm not going to be doing that. Okay, so first thing I want to do is I want to fill, now currently the screen is all filled with black, I want to make it green. And so I will define a couple of colors here. So I'll be using white. And when we define colors in Pygame, we use the RGB format, which is a tuple that accepts three values. The first value is the red value, the second is the green, and the third one is the blue. So white is 255, 255, 255. Black is 0, 0, 0. And we'll also be using a color called grass green. So I'll call it grass green, and I'll call it RGB, and that one, no, it's not this one, is it this one? Okay, this is the color I'll be using, grass green. So I want to fill the screen with this grass green. I don't want it to be black. So inside of our game loop, outside of the for loop where we're checking for the events, fill screen, and in order to do that, we need to use our screen variable screen fill, and then inside the parentheses we need to put the value for grass green. Now if I run the program, it will still be black, and the reason for that is that we did not update our screen. So inside of the game loop, we need to be updating the screen every time there is a change. So this is the command we use to update the screen. So for each iteration of the game loop, it will update the screen. Now when I run it, we see it's filled with grass green color. Now, before we move further, we need to take care of something. Currently, this game loop will be running multiple times per second. So, if you have a fast computer, it will be called a lot of times. If you have a slower computer, it will be called less times. And we need to control this. We need our game to run at the same speed, no matter how fast the computer is. So in order to do that, we need to set the FPS, or the frames per second. And to do that, we'll come here, FPS. So create an FPS variable. I'll give it a value of 60. That means I want that game loop to run 60 times per second. Now also I need to find out if this is right. So I need to create a clock variable, and this clock variable will be equal to the pygame.time.clock object. So in here, after I update the screen, I will tick the clock, and I will pass the FPS variable. So this thing will take care that the game loop will run 60 times per second. And if I run it, there'll be no difference. We're not doing anything currently on the screen. But right now this program will run at the same speed, no matter on which computer we run it. Okay, so the first thing we want to do right now is we want to create the top part of the screen. So here I need to write the name of the program and also the scores of the different pickups, and under them I want to have a line that separates the top part from the bottom part. Now in order to do that, I need to load the fonts first. So after the colors, I'll load the fonts. Now we have only one font, but we'll be using it in different sizes. So I'll call the first one title font, and here inside of this parameter I need to give it the name of the font, and the font name is this one, bunnyfunny.ttf. Now this file needs to access the font, which is inside of the data folder, inside of the font folder, and then the name of the file. So I need to address this data, fonts, and then the name of the font. And when we are loading the font, we also need to give it the size in pixels. So it's a big font, so I'll call it 64. I'll give it a 64 size value. Now besides that, I also want to have a pickup font. This is the font for the different scores, and it will be the same. But I don't want it to be that big, so I'll make it 20 pixels. Okay, so the fonts are loaded and I have access to them. Now I need to use them and create my text value. So the first one will be the title text, and I want to use the title font, render, and I want to print bunny picnic. Now the second argument is anti-aliasing, and I want to set this to true. And the third parameter is where do I want to place the font. Sorry, not where I want to place the font, but the color of the font. So the color of the font, I want it to be white, and then for the background I want it to be grass green. Now, in order to manipulate this text better, I need to create a surface out of it with its positions, and in order to do that, what this line is doing is around the font, the surface of the font, it creates a rectangle, so we can manipulate it better. And this will be, you'll better understand it when we use images. But now when I have that title rect, it can get value, we can place it in a better way on the screen. So I want this thing to be in the center, and I need to pass it two values, the x coordinate and the y coordinate. And let me just do it and then I'll show it to you. Now what we are doing here is we're saying grab the center of this rectangle, the rectangle that's around the text. So we convert that text into a rectangle, grab the center of the rectangle, and on the x-axis, this is the x and this is the y, on the x-axis place it right in the middle, and from the top move it 10 pixels down. So if I want to show this one here, after I fill the screen, I need to put it on the screen. So currently I just I create the text, I convert it into a rectangle, I give it a position. Now I need to place it on the screen. So in order to place assets on the screen like text, images, we need to use the flip function. Screen, actually we need to use the blit function, sorry, screen blit. And so screen is a reference to the window that we created. This is the window. So blit, this is just the the way Python uses to place images or assets on the screen blit, and then we need to pass the asset first. In this case it's title text, and the second one is the title rect. This is the rectangle, so the text and the rectangle. Now when I run the program, oh sorry, this should be title text. So we get the rectangle from the text. We create the text over here using this font. It will be white on a green background. So when I run it, you see that this one shows in the center, and it's a little bit too much. I need to move it down a little bit more. So let me actually make this. Let me do them separately. Center Y 10. It's still too up. Right. Okay. Okay, so it'll be 40. Okay, that's pretty good, I would say. Now, next thing I want to do is I want to add a line under the title, a white line. So under the text that we are blitting to the screen, we're gonna add Pygame has a draw function, so we want to draw a line, and this is a Pygame function. So we want to pass the screen variable as the first parameter. Actually, I want it to be black. This is the color of the line, and then we need to pass the the first point. So the first point, the line will start at 0, 100. So 0 from the X and 100 from the top. Then the second line will be the end line. So the end line will be the window width. This is the end of the screen, and from the top again it will be 100. And then the the last parameter will be how thick the line will be. So I'll make it 5 pixel thick. Now here we have this black line that is separating the top part of the screen from the bottom part of the screen. Now while we're still here, I want to here the top right side, I want to print the scores for the different pickups, and I just want to show them over here. Also, I want to move this one a little bit more, so I'll make it 50. Okay, that's better, I think. Okay, so just like we did with the title text, we need to make we need to take the pickup font this time. So Uh, First we'll start with the, we have three types of pickup. We have the mushroom score text, and it will be pickup font render, and then we'll put mushrooms, and then we want to add the score of the mushroom. And here before the colors I will print my variables or game data. So mushroom count will be 0. We also have tulip count will be 0, and carrot count will be 0. So we want to print mushroom, and we want to append the count. So plus, now we need to convert it to a string, because this is a number and we want to make it a string. Mushroom count. So second parameter is the anti-aliasing. We want it to be true, and the color we want it to be white. Now for the background color is already grass green, so I don't need to pass it, because we're already setting the background color as grass green here when we're filling the screen. So actually I don't need the second parameter. You can leave it, it's not a big problem, but I'll leave the second parameter. Now here we're creating the text, but we also want to make a rectangle around the text so we can better manipulate it. So mushroom score text. Right. So I create a rectangle with that function. I create a rectangle around the text one, and then I can place it. I want to place the rectangle. When we're placing, we always use the rectangle, not the text. And I want to place it in the top right coordinate. So top right, so this is the top, this is the right side. So the first one is the x coordinate, and I want it to be all the way up, but not right next to the border. So all the way up will be window width minus 20. So minus 20, I don't want it to be all the way up to the screen, to the right border of the screen. And from the top, I want it to be 10. So let's see how that will show here. Screen glit the mushroom score text and the mushroom score rectangle, and something didn't work out again. Mushroom score is not defined. Oh, I put too many O's here. Mushroom score. Line pretty safe. Is that? Oh, I placed too many O's in here too. sorry about that. Okay, that should be working right now. So here I have, now because I use the x coordinate, the window width, which is 900 minus 20, so there is a 20 pixel padding between this rectangle. This hole is a rectangle between this rectangle and the right border. And I want to do the same thing for the tulip. Pick up font, render, tulips. Now I'll use the tulip count, true and white. Now I want to convert the text to a rectangle. That way I can better manipulate it on the screen. It'll be again the top right direction. So window width minus 20 on the x-axis, and on the from the top I want to move it let's say 38 pixels. Let me just copy paste this one, and this will be tulip, and this will be tulip. So I'll run it, and there have it, tulips. Okay, and let me just add the caret one. Again, top right, and from the top I'll put it 64, so it's under the tulip one. It'll be caret. Okay, so here we have the scores for the different pickups. So we are done with the top part. So what we want to do next is maybe we want to add the rabbit or the bunny, the image here on the screen. So images. Actually, I want this bottom part to be filled with that grass picture. I want the grass picture under here. So let's actually start with this one, and then we'll add the rabbit. So the background image, I'll call it PG image, and in order to load images, use Pygame image load, and here we pass the path to the image. So it will be in data, images, grass, and that's a JPG image. It's grass JPG. Okay, so just like the text, we need to make a rectangle out of this image so that we can position it better on the screen. Now, where do we want to position this image? I know that this line is drawn 100 pixels from the top, so I want to place it top left. So I want to grab the top left part of the rectangle of the image, and on the X I need to be 0, so 0 from the X. So if this is the program, here is the X. This whole side is the X of the image, and from the top, Y is the coordinate, the vertical coordinate, so 100 from the top. Now I wanna, under the line, I will blit it, which means I will position it on the screen, or I will place it on the screen. I'll pass the image and the rectangle. Sorry about that. So I'll run it, and you see the image appears from the top left. So this is the X coordinate, it's 0 from here and 100 from the top. So our grass field appears correctly. Okay, so we want to show the rabbit or the bunny image. And I believe it's called rabbit PNG. Yes, rabbit PNG. Again, I need to create a rectangle out of the image. And I want, when the game starts, I want to place the image right in the middle of the game window. So I will use the center, and for the X coordinate, if I want the center of the screen, I will pass window width divided by 2. So it's 900 by 2, it's 450, and the height is 600, so it will be 300. But instead of placing these values directly, I'll just use window height divided by 2, because later if you wanna change these dimensions, they will automatically update in here. So what we're left to do is show the bunny image and bunny rectangle. So if I run so we have it right in the middle from the top, and from on the X coordinate and on the Y coordinate. Now probably the next thing we want to do is move the image. So in order to move the image, we need to listen for keyboard events. So we'll be moving the image using the arrow keys on the keyboard, and now we also want to listen not just for the arrow keys, not only when I press the key, but also when I press and hold the key. I want the image to move continuously, so if I press the bottom, the down arrow key, and hold it, I want the image to continue moving. I don't want to press multiple times the down arrow in order to move the image. I want it to move. If I press it, I want it to move continuously. So in order to catch the pressed images, we need to use a special Pygame command and catch all the all the keys that are pressed. So when the game loop is running, on each iteration it will get all keys that are pressed. You need to store them in this variable. So let me put a comment here. So when I get the moved keys, I can check which keys is pressed. So let's start with the let's start moving on the horizontal axis, left and right. So this is an array of all pressed keys. So if keys, and Pygame gives us a couple of values that we can check. Different values apply to different keys on the keyboard. So if I want to check for the left key, I will use k_left. If it's the left key, I want to move the bunny. Now, before we move the bunny, actually, we forgot something. So here in the game data, we need to say with how much we want to move the bunny. So I will say it as velocity, and I'll make it 5. So move 5 pixels. Now here's the rectangle. Now when I'm pressing the left key, I want to move to the left. That means I need to subtract from the x. I need to get the x coordinate minus velocity. So every time I press the left key, update the x coordinate of the rectangle bunny and move it 5 pixels to the left. So let's test it out now. So I will press the left key and it moves 5 pixels. Now if I hold it, the bunny will move continuously, and that's what I want. Now as you see, when I run the program, the bunny will move indefinitely to the left, and I want to add I want it to move next to the left border, but I don't want it to move over the left border. So if the left key is pressed, and also I need to check that if the left key is pressed and bunny left. So because we have a rectangle around the bunny, we can use not only X, Y and center, we can also use left, right. So we'll grab the left side of the bunny, and bunny left is greater than 0. So this actually, let me actually write make a hold on a second, guys. In order to see better what we are doing, I'm gonna add a rectangle around our bunny image. So when I make the image here, I will use the Pygame draw, but I'm not gonna draw a line like we draw a line here. I'm gonna draw a rectangle, and I will pass the screen, and let me pass, what kind of colors do we have? I will add a red color here. It will be 25500. So the color will be red. Bunny rect. This is the rectangle around the bunny image. And the thickness will be 1. So when I run it, you see there's a red border around the image. Now here you see I'm checking if the left side of the rectangle of the bunny is greater than 0. So this is the left side of the bunny. So if this is greater than 0, move it. But if it's not greater than 0, stop. So when I start moving it, now the left side is more than 0, because 0 starts from here. So when I reach 0, it stops. You see I cannot move any more to the left. So the same thing I want to do for the right side. If keys, Pygame key right. So if I press the right key and the bunny rect, this time will be right. So if the right side is less than the window width, the window width is 900. So if the right side of the bunny is less than 900, do not, only then you can move it. So the rectangle X, I will add velocity. So if I move, I'm pressing the right key right now, the right arrow key, and when I get to the window width, it will be in the borders, within the borders here. Okay. So next thing we need to do is do the same for the up and down. If keys Pygame key, and let's do the up one. Now you remember that on the top we don't want it to go all the way to the top, because we need to go up to the black line. So we need to make sure that the top of the rectangle of the bunny is less, and I believe it was it was 100. Bunny rect. Now this will be the vertical coordinate, so y minus velocity. Okay, sometimes it's not working. Pygame key up. And the bunny is greater than 100. So I can move it, but when I reach 100, you see I cannot move top. Actually, I'll make it 110, so it's not all the way up to the line. So this is as much as it goes. Okay, and last one, we need to add the bottom. So if the down arrow key is pressed and bunny bottom is less than window height, so we don't want it to move under the bottom line, only then update the Y position of the bunny. Y, and when we're moving down, we need to add to the Y. Okay, so right now our bunny should be constrained within the Okay, it is constrained. Good, we can move the bunny freely around. And when I press a key and hold it, the bunny will keep on moving. And this is the effect that we want to do. And you can press simultaneously, for example, up and right to move diagonally if you want to. Okay, so what we want to do next is probably we want to show the mushroom. And a little bit later we'll make the pickups appear randomly, but for now I just want to show the mushroom. So under the bunny image, I'm gonna make the mushroom image. Actually, it's a toadstool. Again, we need to create a rectangle around the image. Now, we want to show the image randomly at a random position. But for the time being, I'll just show it on a predefined position, and then when the game is almost done, we'll randomize it. So, mushroom that. Say X. I'll place it under the bunny. So window height plus 100. So we have the mushroom here, and actually let's add also a border around it. So we can see where it is. So the next thing we want to do is when we collide with the mushroom, we want to remove the mushroom and place it on the random spot somewhere else. So after the logic for moving the bunny, we'll check for collision. Now, in order to detect if two images collide with each other, Pygame gives us a very useful function called collide rect. So if the rectangle of the bunny collides with the mushroom rectangle, print collide, and we're just gonna print collide to the console to see if this is working. So here's our console. Now when I move the bunny of the image, you see it prints collide. So when we collide, what we want to do here. So here we need to write the logic. Now, the first thing we want to do is we want to update the score for the mushroom. And here, this score needs to be updated. This one. Actually, the mushroom count needs to be updated. And first we all start with zeros, and then we need to update it. And then we'll add the mushroom will be updated by 1, tulips will be updated by 2, and carrots by 3. So I will add here the scores for each of them. 1, 2 will be 3. So if we update with the mushroom, we need to update the mushroom count. Mushroom count, the mushroom score. And currently, if I run this one, it collides, but it doesn't update. And the reason it doesn't update is because we create here the scores, the text score, but we need to also place it here. We need to update it just like these images. We don't need just to place the score text. We also need to make it so that it updates. In order to do that, we're just gonna copy this line and place it before the line actually. So look at the score for 0 when I collide here. Okay, yeah, it's colliding, and that's why it's updating continuously. So when it collides, we need to remove this one. Now, in order to generate a random position for the mushroom, I need to import the random module. And here, when I update the count, I need to add a random x and y coordinates for the mushroom image, for the mushroom rectangle. So mushroom x. So I'll use the random module and generate a random integer. Now for the x, it will be from 0 to window width. And for the y, it will be a random integer between, now the top is 110, so I don't want to, place the mushroom in the top, in the very top where we have the text. I need it in the bottom part where we show the grass image, and window height. Now the y image, the mushroom image is 32 pixel in each direction, so I need to subtract 32 so it doesn't appear under the screen. So when I generate the image, I don't want the image to appear over here and start from over here and the body will be here, so I need to subtract minus 32 from the image. So let's test this out. Random int. Okay, this is rand int. see. I'm picking the mushroom, and every time I pick it, the score increases by 1. Okay, this thing is working nicely. Now, there's one problem with that script. What happens if the mushroom is generated in a position where is the rabbit? For example, let's say the rabbit is here. It is the mushroom, and the mushroom is generated on top of the rabbit. This will update immediately, and then the mushroom will appear somewhere else. It's kind of a bug, but we want to avoid it. So we want to, when we're generating the mushroom or the pickup, we don't want it to generate where the rabbit is, inside of the coordinates of the rabbit. So what I'm gonna do is I'm gonna create 2 functions. Maybe here after these images. I'll create 2 functions for generating the x and y coordinates of the pickup, so that they don't collide with the bunny image. Pickup x, and I'll pass the bunny rectangle so I know where the bunny is. So x will be equal to this thing, x will be equal to this thing, and actually here we also place minus 32 because we don't want it to, on the right side, to the image to appear outside of the game window. And then we'll check if the bunny rectangle, the x, is less than or equal to x, or is less than or equal to the rectangle x plus if x is between the left and the right, I want to generate it again. So on the function we'll generate an x coordinate, and if that coordinate is between the left side of the bunny image or between the right side of the bunny image, I want to generate it again. And if this thing is true, this while loop will run, but if it's false, it will get out of the while loop, and then I will return the x coordinate. And I'll do the same for the y coordinate. In this case I wanna take care of the 110 pixel on the top. Rect top is less than or equal to y at bottom. So if this thing is, if y, the y coordinate is between the top and bottom, y. Okay, so Here I will generate y. Now this should be working. We're just making sure that the coordinates don't coincide with the pickup. Okay, so now sometimes we're not always gonna have mushrooms. Sometimes we'll have carrots and other pickups. So I'm gonna refactor that code. I want to use a pickup image that will be updated accordingly. So in order to do that, I will have to actually, you know what, I will create a pickup image here, mushroom image. The pickup image, and I'll set it to the mushroom image. And then I'll use the pickup here. But I need to create a rectangle around it first. So I'll have only one pickup image, but the image inside of the pickup image will change. So one time maybe I'll have a mushroom, then I'll have a carrot, then I'll have a grass or something like that. So pickup, right. Okay, let me try it out now. Oh, what? Huh, wait a minute. So I need to generate so I believe the problem is that here when we are updating the screen, we need also to change here the pickup image and pickup rectangle, and here we have the pickup, but we need to move to make the border around the pickup and not around the mushroom. So, and also we don't need a mushroom rectangle, because the rectangle of the image will be used through the pickup rectangle. So when we're changing the image for the pickup image, we'll be working through the pickup rectangle. So here in the beginning we're loading the mushroom image, but then we'll be randomly generating a different image for the pickup rectangle. Wait, what? Okay, so this is working. Let me try it again. So, okay, yeah, it's working now. So here we're not working directly with the mushroom, we're working with the pickup, and we'll be placing different images here. Okay, now the mushroom is easy. Actually, let's load the other images that we'll be using. So we'll be using the tulip image and the grass image and the carrots. Yeah, this is PNG and this is JPEG for the background, so it's okay. We'll also be using the plant. Now if I change the pickup image from mushroom image to grass image, I get the grass. Now grass shouldn't be pickable. We need to dig it out first before we can pick it up. So this is not pickable and we need to work on it. And also we shouldn't update the mushroom count, but we'll fix it. Okay, so let's see. One image. So yes, in order to make this not pickable, we need to add a variable is pickable or collectible, maybe it's equals to true, is collectible. So the mushroom by default is collectible, but if it's not collectible, we don't want to get it. So the first thing we want to do, actually, I'm gonna make this false for the time being, because currently we're showing the grass, which is not collectible. And the first thing I want to do is I don't want to collide. I want them to be like an invisible wall between the two images, so that the bunny cannot go on top of the grass image. So is collected, the grass and the plant are not collectible, so they'll be false. And that means when we are moving here, we need to check if this is collectible. If is collectible, then move it. Collectible. If it's collectible, just move on top of it. For example, the carrots, the tulip, the mushroom will be collectible. Now, what happens if we have plant or grass images? They're not collectible, so we need to add additional logic here inside of the moving logic. So if it's not collectible, we need to do something else. And just show you guys. And this is not moving because I made it false. So do you see how there is this image? Now what I want to do is, for example, when I'm pressing the down key, I can easily make it so that if the bottom of the rabbit is greater than the top of the grass, I can move. But if the top is bigger than the grass, for example here the top is, you see guys, it's overlapping, so it should be 0. The difference, actually it will be negative. There'll be a negative difference between the top and the bottom. So I can make it so that it doesn't move, but there'll be a small problem. And let me show you. Actually, let me just turn it off here. Veritable false. So let's try it for the bottom first. Else if the bottom is greater than the top of the pickup, I can still move. And I need to make it again. Actually, wait a minute. It's false. If the bottom, actually, if this is less, it should be if it's less. So I can move, but what? Now I'm pressing the down button and it doesn't move, because this condition is in effect. Actually, this condition is not applying, because the bottom is not less than the top. The bottom is there's like a wall here. It's like an invisible line, and I want to avoid it. I want the image to move. It's beyond the, if it's under the grass image. So pretty much what we need to do is we need to take the difference between the top and the bottom, and I'll call it delta or difference, or you can call it whatever you want. So I'll take the difference between these two values. Bottom, and then I'll check it in here. So and I'll explain what I'm doing here in a minute. So I get the difference between the top of the pickup and the bottom of the bunny, and I also want to make it like a so that they don't touch, but there's a 10 pixel difference between them, 10 pixel padding between the two images, so they're not right next to each other. So if this difference exists between them, if it's between 10 and 0, then I want to move. But if this is not true, then I don't want to move. But in order to remove that invisible wall, I also want to make sure that the right of the bunny is less than the left of the pickup, so I can move it underneath. And let me actually guys show you how this is working. Well, it needs to generate it under it. Okay, so I can move it, and I haven't applied the logic for the other ones, but pretty much I want to move. If I'm under the grass image, I want to move the bunny again. So that's what this is doing. So let me actually add it for the other ones. This was for the down, so let's do it for the up. Down. So here we'll get the top and the bottom of the pickup. And it will do the same here. So this is top and bottom. Pick up lines, this is nice. Should be underscore. Okay, let me add the left and right, and you will see what's going on. So this is the right. So this is the padding. I just want to have at least 10 pixel padding between the two, so they are not right close to each other. Or Okay, so I hope this thing is working correctly. So when I come here, I cannot move, but underneath I can still move. There is not that invisible thing, that invisible wall. See, it's not pickable, so I cannot pick it up. I cannot come over it. Okay, so the next thing I want to do is I want to change the cursor here to a shovel. So I want to use that cursor when I'm on top of the a non-pickable item. So now the cursor is just an image, so it's pretty much like the image. Shovel, spade. So here's the cursor, but I need to show it only when I'm on top of a non-collectible item, non-collectible pickup. Should we? We also need a variable that will tell us if the cursor is visible or not, if we should show the shovel cursor. So now by default it will be false. But if it's true, we want to show it. So if is cursor spade, and we want to show it. Now we didn't get a rectangle for the cursor, the spade cursor, because it's not an image that we want to show on the screen. We want to show it on top of instead of the default mouse cursor. So in order to get the position of the mouse, we need to use a Pygame function from the mouse, get position, get pos. So when the cursor is visible, it will show the cursor, this cursor, the default one. Now if I make this thing to true, see, it's showing the cursor. And of course when we're showing the default cursor, we need to hide the mouse cursor. Now in order to do that, here in the event loop where we're checking for events, and currently we're only checking for the quit event, we can check also we can check for the non-collectibles. So if we are showing a non-collectible item, this is we have only two non-collectible items. This is the grass and the plant. If the image is one of them, it means it's non-collectible. We need to see if the pickup rectangle collides with the mouse pointer. So in order to do that, we need to write another conditional. If pickup rectangle, and to check if it collides with the mouse cursor, we use collide point, and then we pass the mouse coordinates of the cursor. So if they collide, now we need to hide the default cursor, and in order to hide the default cursor, we use Pygame mouse set visible to false. This will hide the cursor, and then if cursor state will be equal to true. This means show the default, the custom cursor, and when set to true, this function will execute and the screen will display it. So if it's true. Okay, let's test it out now. So currently the cursor is the default, but when I hover over this grass image, it turns into a shovel, and it stays a shovel. Now when I hover out, I want to remove the cursor. So here we're checking if it collides, but if it doesn't collide, we want to do an else clause, and we wanna do this thing. So we wanna show the default cursor true, and we wanna set this to false. And when it's set to false, this thing will not execute, so it will not show it. And let's test it out. So when I move the cursor, it changes into a shovel, and when I hover out of it, okay, so that thing is working. This is good. Now the next thing I want to do is, when I dig the grass or the plant, I want to show the corresponding image. So actually, before we do that, I think we need to load the tulip and the carrot images, because when we click on non-collectible images, we want to show those images. So maybe we can do them over here. So these two images are not collectible. When we dig them out, they will give us the collectible versions. So the one is the tulip, and the other one is the carrot. So the grass image will give me the tulip, the plant image will give me the carrot. When one of these images show, they'll be non-collectible. We need to click them in order to show the collectible versions, which we can then eat using the rabbit. So actually, maybe we can just start creating the logic. Here for the pickup image, we're using the grass, but actually let me change this. I'll create a pickups array that will hold all the versions that we have currently. it will have it'll be an array of tulips. So the first one will be the mushroom image and the score. So I will randomly generate a tulip from this array. The second one will be the grass image, and it will use the tulip score. And the third one will be the plant image, which will use the carrot score. So in the beginning, the pickup image will take the mushroom image. I want to start with the mushroom image. And here, when I collect the collide with the image, I actually want to make sure that it is first collectible. It's collectible, and by default the mushroom will be collectible. We will always start with the mushroom image. It will be collectible, so if it's collectible, I want to check out the score of the image. Actually, I think we forgot to do that. I'll use a pickup score. Now the mushroom is 1, so I'll start by default as 1. And then here I'll check if the pickup score is 1. If pickup score is 1, I will update the mushroom count. If pickup score is 2, I will update the tulip count. Actually, I'll do it else, this is the third one, carrot count will be updated with the carrot score. Okay, now if it's collectible, I will update the corresponding score, but then I need to generate a new pickup. So I'll generate a new pickup. Actually, these are the coordinates. The coordinates just make sure that the new pickup is not placed on top of the bunny image. So I'll call the pickup variable, and it will choose a random one from the pickups. So this is the pickups that we created over here. So it will choose a random a random tuple from one of these. Now the tuple will have two values, the image the first one will be the image, the second one will be the score. So the pickup image by default is the mushroom image, but when we start the game loop, I will generate a new one. Every time I collect a pickup, it will generate a new pickup. And the score will be so if I generate the grass image, the score will be 2. If I generate a plant image, the score will be 3. And then I generate the position of the pickup. Now, I also want to make sure that if the pickup score is greater than 1, so if it's 2 or 3, it's non-collectible. It is non-collectible because 2 and 3 are the grass image and the plant image, and they're not collectible. So we'll set is collectible to false. And let me run this one. Carrot. Oh, it's carrots. Okay. So this should be carrots. So by default, the first image is a mushroom, and when I go over it, and I can't because I forgot the is collectible by default is true. So when I go to the mushroom, it will generate a grass image, and when I get here, I can't get it. I move the cursor. Oh, I didn't write the logic for the clicking, for the click of the non-collectible image. Okay. So so here, if it's not collectible, we are checking if this thing collides. If they collide, if I click on the image, I want to do something here. Now, currently we are hiding the default cursor, showing the custom cursor, but I also want to check if I press the left mouse button. I mean, if the mouse button is pressed, and we check if a mouse button is pressed when we check for the mouse button event. So if event type is equal to pygame dot mouse button down. So if I click the mouse button, I'll print clicked. So if I click here, it doesn't show anything, but if I click on this one, actually it needs to be, so this is not collectible. Mouse button, oh, I misspelled it. Mouse button down. So the mushroom is collectible, but here I have uncollectible, and if I click it, you see it shows here. Okay, so if it's clicked, now I need to check which mouse button is pressed, because the I hope this is clear to you guys, because I know it's getting kinda a little bit difficult here. But when I'm showing the grass icon, I wanna make the left. I wanna dig it out with the left mouse button, and the plant I want to dig it out with the right mouse button. So when I click the left mouse button, I want to pick it, and when I click the right mouse button, I want to dig the plant one. So in order to check which mouse button is clicked, we use event button equals to 1. 1 corresponds to the left mouse button, 2 corresponds to the scroll if you click with the scroll, and 3 is the right mouse button. Left mouse is clicked. Left mouse button is clicked. If this is 1 and we want to make sure that the pickup score is 2. Pickup score is the tulip. So we don't want to click on other images. And then we want to change the pickup image to tulip image. So I want to show the tulip image. And then is collectible will be true, because the tulip image is collectible. So I want to change the tulip image, and I want to hide the cursor, the default cursor, because I don't need to show the shovel cursor when there is a tulip, because tulips are collectibles. And also I want to show the default set visible to true. I want to show the default one. If left mouse button is clicked, right mouse button is clicked. So if event equal to 3, that corresponds to the right mouse button, and pickup score is 3, this means this is the plant. Pickup image is equals to the carrot image. And then I wanna make these things too. Okay, let's try this thing out. It should be working. Okay, this should be 2. So the mushroom is collectible. Now here I'm clicking with the left mouse button, but I cannot because this is a right mouse button. So when I click it, I can pick it up. Okay, grass. So with the right mouse button I cannot click it, but with the left mouse button I can click it and I can collect it. Again, left mouse button, collect it. Now, two things are missing. First of all, when I'm showing the plant, this is the grass, it correctly shows the spade is showing to the left. But here I want the spade to show to the right, which indicates I need to click the right mouse button. So I need to fix this one, and also I need to fix these two. Actually, these two are very easy to fix. We just need to grab this one, the tulip score text, and place it over here, and then the carrots text, place it over here. So this should be working. So I'm picking mushroom. Now the tulips should be 2, because tulips give me 2 and the carrots give me 3. So okay, that's working correctly. So the next thing I need to do is update the cursor. So now I can create a second cursor, but and show the second cursor, but I'm gonna do it in a different way. I will use transform, the transform function from Pygame. And maybe I will create another variable is flipped, and by default it will be false. Is flipped is false. So here, when we're collecting stuff, we can add logic for when we need to flip the cursor. Now, if pickup score is 3, that means that the plant icon is showing and I need to flip the cursor because we dig the plant icon using the right mouse button. And I want to check also that it is not flipped. If not is flipped, I want to flip it. And I'm checking for this condition because the plant icon might appear and then the next pickup might be also the plant icon. So this will stay flipped, and I don't want to flip it again. I want to make it flipped. So only if it's not flipped, then I want to flip it. The spade cursor, I'll use Pygame and then transform, flip. And what do I want to flip? I want to flip the spade cursor, and I want to flip it on the x-axis and false on the y-axis. And then I want to put is flipped to true. Now, if the pickup is not free, again I want to check if is flipped. I want to flip it, because if it is flipped, I don't want to show the flipped version. I want to check, move it back to its default. And I'm pretty much doing the same thing here. But this time is flipped will be false. And let me check this one now. So okay, so now the grass again, it's left, flip left. Okay, so you see how the plant, it's showing the right version. So I'll click the right one, and then it's again a plant, and when I move it, it is right one. Okay, so let's see if the grass appears left one. Okay, plant. Okay, the grass, and it's showing the left cursor. I mean, it's left oriented. Right. So left mouse, right mouse. Okay, this is working. Well, believe it or not, we are almost done. We just need to add the sound effects. And probably I'll add them before the images. It doesn't matter where we add them. So we'll have two sounds, the eat sound and the dig sound. And we use the Pygame mixer.sound. And data sounds 8. Yeah, it's the eat and the dig one. So now I will play the dig sound when I'm digging non-collectibles. So dig sound play, and I'll have the same thing for the other collectible. And the eat sound, I'll play it if it's collectible. And let's test it out now. Okay, that thing is working, and if you want to, guys, you can also add a background music that plays continuously. And let me see how. So in order to play it, we just use the play function. Pygame. Now the play option gets two parameters. The first one is -1, that means play infinitely. So that says play it in a loop. If you put 1, it will play just once and then stop. 2 will play it 2 and then stop. -1 means play it continuously. And then where do we want to start? And I want to start from the beginning. Now the volume is a little bit higher and it overpowers the sound effects. So we can say the set volume, and it accepts a parameter between 0 and 1. So I'll make it as low as possible. Okay, and that's pretty much the game, guys. So I hope it's kind of understandable, but if you have any questions, just write in the comments below. Now the last thing I want to show you guys is how to make this this game into an executable, because currently if somebody wants to play this game, he needs to have Python installed, and then he needs to write the Python, the game.py file. So let me show you how we can. Actually, we don't need the editor anymore. We need to convert this thing into an executable file. So we need a package called PyInstaller. So I'll open the command prompt, cmd, and I'll write pip install PyInstaller, and I have it installed. So oh no, I don't. So we wait for this thing to install. It takes a while. Okay, so when this is installed, go to the your game folder, and in here we have the game.py, the script file, and also the assets of the data where all the images, sounds are stored. So In here we need to run the cmd, and I have the git bash, or you can open PowerShell here. So if you press shift and right click, you get this option, open PowerShell. Now I'm using git bash, so I'll open git bash, but it doesn't matter which command prompt. You can also use this one. So if you open cmd, place it here, you can just cd okay, so you can also use the cmd. Let me show you, because maybe not everybody has a git bash or other terminals. So once you're here, we run the PyInstaller, and then the name of the script file. Our script file is called game.py, and then you'll give it the direction of one file. So we want to create a single file, no console, meaning we want to run our executable without a console, so just the executable. Press enter and this will generate some files inside of our folder, and let's just wait. Now when it's done, you will see a dist folder, and inside of this folder you will have a game exe. But if you try to start this file, it'll give you an error, and the reason why we have an error is because we're missing the data folder. So I will copy this folder, I will place it inside, and now I'll start the exe file. And there we have it. If you want to send this to somebody, we just need to zip it. And you can say and this is pretty much the game. When we unzip it, if we unzip it on the desktop, and I start the exe from here, it will still run. And one thing we actually forgot to do is remove the borders. But here, did I close new editor? Yeah. So yeah, we forgot to remove those borders around them. This one. So I'll just comment them out, and I'll run it from the install. And here we have without borders. Okay, well, that's all, guys. I hope you liked the tutorial. I know it wasn't perfect, but hopefully the next ones will be better. And thank you for watching, and hope to see you soon.